Hello folks, welcome back. Today we are going to discuss linked list cycle problem. In this problem, we are given a linked list and we want to return that if there is a cycle present inside the list or not. So what is the criteria of when a cycle is present inside a linked list? So this linked list would, if you keep iterating through it, keep going to the next element, you would never reach an end and you would always keep iterating through it. Okay, so that's why it's important to figure out if there is a cycle in a linked list or not. So given a linked list, what would be your approach in solving this problem? So one of the approach, and I think which is also the easiest and simple approach, is we would have two pointers. Okay, when we say two pointers, what does it mean? So we would do it like this, like one is a fast pointer, one is a slow pointer. A slow pointer does iterate like one element at a time, which means if we are at 3, we would go to 2, then we would go to 1, then we would go to 4 and 2, and simultaneously like that. Another pointer would move by 2 elements. So from 3 it would jump to 0, from 0 it would jump to 2, and then it would keep iterating like this. So if there is an collision, like if before reaching the terminal state, like say before the fast or slow or any of those elements, I think the fast elements which is going faster, if it reaches at the end of the linked list, which means that there is no cycle in the linked list. But if there is a match, like if both the elements at some point in time reaches to the same node, that means that there is a cycle in the linked list. Okay, with this approach, let's try to solve this problem. So we would have a list node which is given as per this definition. Okay, so there is a slow pointer, and we would point this to head to start with, and similarly there is a fast pointer. Okay, and fast pointer is also pointing to head. Okay, this node. Okay, so now what we will do, we will start a while loop, and this while loop we would see, because we are iterating the fast element faster, so there is a possibility that the fast element would reach the terminal or the end node quickly. So we should check this one, fast not equal to null, and fast dot next not equal to null. Okay, if this is the case, which means we are not in the final state, so we would move the slow element by 1, and we would move the fast element by 2. Okay, and if we reaches a condition where fast is equal to slow, it means that there is a cycle. Otherwise, if we process it thoroughly, we would come out of this while loop and we would return false. Okay, with this intuition, let's try to execute it. Okay, so our answer is accepted. Let's try to submit it. Okay, so the runtime is 3 milliseconds, which is faster than 42.3% of the submissions. Thank you folks, see you in the next one.